Transport strike, we have to conduct these asynchronous classes. So according to the Department of Education, learning must continue. So our routine for this asynchronous session, so after this lecture discussion, you will answer the closure activity or the exit pass. If you have questions, clarifications on today's discussion, you can put on your questions on the Google Forms. Okay. Then the seat work or quiz will be also sent through our group chat, and we will check the seat work once we return to face modality, hopefully on Monday. Okay, so let's start. Our today's topic is limits of transcendental functions, specifically exponential, logarithmic, and trigonometric functions. So the objectives or the learning outcomes at the end of the lesson, the learner shall be able to number one, compute the limits of exponential, logarithmic, and trigonometric functions using tables of values and graphs of the functions. Then we will evaluate the limits of expressions involving sine t over t, 1 minus cosine t over t, and e raised to t minus 1 over t. Okay, so we use the variable t instead of x. So I hope you're not confused about that. Using tables of values. Okay, so let's start. So transcendental function. So let me define. Transcendental functions are functions that cannot be expressed as a sum, difference, product, or quotient of algebraic expressions. So basically, what are transcendental functions? The functions that are not algebraic. So from the word transcendental means the functions is not algebraic. So some examples of transcendental numbers are pi and Euler's number e. Okay? So what are the properties of limits of exponential functions? So when we are getting the limits of so we will start with exponential functions first. Okay, so what are the properties? So the limits of exponential functions. So there we have two base exponential functions. So we have the Euler's number and the base b or non-Euler's number. So and an Euler's number is a irrational number like pi. Okay, so the limit of e raised to x as x approaches a is e raised to a. Okay, so if you notice, it's just a direct substitution where a is an element of real numbers. So for b, if your base is b, so b must be greater than 0, meaning it must be positive, and b cannot be equal to 1. Okay, take note of those properties or conditions. So the limit of b raised to x as x approaches a is just b raised to a. Okay, let us focus first at e raised to x. So the limit of e raised to x. Let's have the first example, evaluate and investigate. Okay, so the limit of e raised to x as x approaches 0. So I will give you 1 minute to think about what will be the limit. You can pause the video. Okay, so what is your answer after evaluating? Based on our previous discussion, we can evaluate this using direct substitution. And if we will substitute 0 to e raised to x, so it will become e raised to 0. Logically, any number raised to 0 is 1, right? But again, we are going to investigate, so we will use table of values. I prepared um, here some values, negative 1, negative 0.5 up to negative 0.00001. So if you notice, this is approaching 0 from the left side. Okay? And this is the equivalent value if you will substitute this x to e raised to x. So if you will notice, it is going closer and closer. Your f of x is approaching closer and closer to, it is getting closer and closer to 1. Approaching from the right, so from 1 to 0.00001. Again, the same with our approaching from the left. So the function is, so if x is equal to 1, and the function e raised to x is equal to 2.718281828446. And this value is, and so this is the equivalent of the Euler's number. Okay, so if you will type the Euler's number to your calculator, by the way, if you will search what is Euler's number, it was developed by a Swiss mathematician during 17th century. Yeah. So it's Sir Leonard Euler. So one of his um, formulas or discoveries was the Euler's number. And so the value of the Euler's number is 2.718281. So yeah, so e raised to 1 is this. Then of course approaching 0 from the right side. So again from 2.7 it came to e raised to x will become 1.000001. So it will be approaching also to 1. So therefore, conclude based on this proof using table of values and direct substitution that the limit of e raised to x as x approaches 0 is 1. So proceeding to the graph, we can use the graph of f of x is equal to e raised to x, okay, to determine its limits as x approaches 0. Yan, from the left side and right side, it will converge to 1. So the figure below is the graph of f of x is equal to e raised to x. Okay, so let's have some other values. The same function e raised to x. So the limit of e raised to x as x approaches 1, if you will check the graph again earlier by our table of values, it is 2.7 something, right? Yeah, so that is the value of the Euler's number, 2.718. So it is a irrational number like pi. So wala siyang ending, non-repeating, non-terminating. Okay, so based on the graph, and yan, to approximately 2.7. Letter B, as x approaches to, again, the limit of e raised to x. So if you will check the graph, as x approaches 2, it is up there. If you will count 1, 2, 3, 4, 5, 6, 7, 7 point something, right? 7.5 based on the graph, 7.3. Yeah, so 7.389 something. Okay, so e squared. That will be the direct substitution. And letter C, e raised to x. So direct substitution, e raised to negative 1. If we will look at the graph, we will investigate and check the graph. It is below, yeah, so the f of x will below 0.5, right? So, oh yeah, 0.367. Okay, so that is how you will evaluate e raised to x based on graph, the limit of e raised to x using graph. Okay, so if you have any questions, so you can put it in your closure activity, exit pass. So we will proceed with another example. The function is e raised to x minus 1 over x. So this is the function. So you will evaluate what is the limit of the function as x approaches 0. So using direct substitution, so e raised to 0 is 1 minus 1 is 0 over 0, right? So it will give us indeterminate. When we have an indeterminate answer, we must find another way in finding its limits. So we can use table of values, right? What else? Using graph. Yeah. So we will use table of values. I prepared approaching from the left and approaching from the right table of values. Yeah, so direct substitution with our values of x, I came up with these values. And if you will notice, it is will approaching from the left, it will be closer and closer to 1. So let's see, approaching from the right, again, it is closer and closer. So approaching from the right of 0, di ba? So it will be closer and closer to 1. So therefore, we can have an answer. What is the limit of the function as x approaches 0? It is 1. So can we use this evaluation as our means of evaluating problems, questions involving this setup, e raised to x minus 1 over x? Actually, this is one of our objectives earlier. The variable we use objective is e raised to t minus 1 over t. So the same principle, the same scenario, e raised to x minus 1 over x. So whenever you encounter this situation or this function, or you came up after evaluating and you came up with e raised to x minus 1 over x, you can value of the limit as just 1, okay, not indeterminate. Let's have an example. So evaluate 2x squared e raised to x minus 2x squared all over x cubed. So what is the limit of that as x approaches 0? So using direct substitution, okay, so what is the direct substitution? What will be the value? Okay, so it is indeterminate, 0 over 0. So we must find a way in finding the limit aside from direct substitution, or before we use direct substitution. So let's evaluate. So if you will notice, in our numerator, we have common factors, right? 2x squared. So we can factor out 2x squared. And let's see from after factoring, we can, if we can cancel something. Ano, 2x squared e raised to x divided by 2x squared is just e raised to x. Then the other term, negative 2x squared divided by 2x squared is negative 1 all over x cubed. So if you will notice, we factor out 2x squared and we have a denominator x cubed, so we can cancel out x squared. Then we will left with, if you will notice again, the constant 2, I put it in the front because properties of limits, if you have, let's go back to the property of limits, that if you have a constant, you can put it in front of the limits, right? And we will left with e raised to x minus 1 all over x. So finding the limit of that as x approaches 0, and that is just equal to 1. Okay, so based on our previous function problem, and that is one of our objective, limit of exponential function. Okay, so basically it's just 2 times 1. So the limit of the function given as x approaches 0 is just 2. So you can double check that using tables, or this one, I prepared a graph. Yeah. So as x approaches 0, and if you will notice, as x approaches 0, coming from the left side, is it will approach 2. The f of x will approach 2, and approaching from the left also is also approaching the f of x 2. Clear? Question? So if you have a question, you can include that in your evaluation after this session. Let's have a review. The limits of exponential functions. So we are done with e raised to x, some examples of e raised to x. Now we will proceed with b raised to x. So non-Euler's number questions. Actually, it's just one because some of the exponential functions question, the faster method. So there is a shortcut, but that will be discussed after the derivatives, or on the derivative part of calculus, differential calculus. Okay, so we will just have some example of b raised to x, a simple example. The seat work or quiz will be sent also via group chat, in our group chat, and we will check that on Monday tentatively, hopefully there will be classes on Monday. We will check all the seat works we have done this week. Our example, you were asked to evaluate 3 raised to x plus 1 plus 5. Okay? So the limit of that as x approaches 0. So if you will use direct substitution, there will be no problems, right? Because it's just 3 raised to 0. So 0 plus 1 is just 1. Okay, so 3 raised to 1 time plus 5. So the answer is 8. You can double check that using graph or table of values, but direct substitution already gave us a arbitrary L value. So it's up to you. You can double check. Okay? So that is my only example for b raised to x. And yeah, so for our last activity will be the exit pass. And I hope you have a good day today. Tomorrow we will also have another lecture. Continuation of this, um, finding the limit of the inverse of exponential will be logarithmic function. Okay, so goodbye and God bless.